It tells us that Gator Recycling was offering a promotional price to break into the market, but once it raised its price, the sales decreased. So it raised its price from $3,317 to $3,632, and sales decreased from 496 units to 398 units. It's asking us to use a log linear demand approximation and to find the price that would maximize profits from these trash compactors if the constant variable cost is $2,930 per unit. So instead of using a straight line to approximate demand, like in the last question, now we're going to use log linear form, which is quantity is equal to A times P price raised to the eta, where eta is the constant price elasticity of demand. So right now we have two different equations. We have a price of $3,317 giving us 496 units, and we have a price of $3,632 giving us 398 units. We want to divide both of these, and the reason we do this is right now we have two variables, A and eta. If we can cancel out those A's, which we see that we can do by dividing these two equations, now it's simple enough to solve just for eta. On the left side, we have 496 divided by 398, which is just going to give us a number. On the right side, both the numerator and the denominator are raised to the same exponent. Whenever that happens, you can take that exponent outside in parentheses and just divide those two numbers. So let's see that. 496 divided by 398 gives us 1.24623. On the right side, 3,317 divided by 3,632 gives us 0.91327, remembering that that whole thing was raised to the eta. So now we're ready to solve for eta. We need to take the ln of both sides. On the left, the ln of that number is just going to be a number. On the right, the exponent, when you take the ln of a number, becomes the coefficient. So the eta, that was the exponent, is now the coefficient. And the ln of 0.91327 is just going to be a number. We can solve for those two numbers, and now we're ready to solve for eta by dividing through. And we see that our price elasticity of demand is negative 2.4263. So remember, we were given log linear demand, which means we can find the optimal price by using the equation marginal cost times the elasticity of demand over 1 plus the elasticity of demand. We're given marginal cost in the question, so now we can just plug in all of our components, and we can solve for our optimal price to be $4,984.